Well, hi, and welcome to my shop here on June 9th. Oh boy, am I ever stalled in action now. So, after the last session, a video for which I just posted a few minutes ago, where I come up with this idea that maybe somebody literally re-engineered this radio so it could operate with 6-volt tubes instead of its original 1-volt tubes. And what I'm talking about is the heater voltage. This is a battery-operated radio only when it was built. Typically, in a battery-operated radio, you run the tubes with a low voltage supply, 1 volt, literally a 1.5 volt battery. It would have been a fairly large battery to last a fairly long time. That's a major power consumption in a radio like this, are the heaters. A couple of watts per tube. The other circuitry and the actual high voltage, all that stuff, not much power involved with that. So you have a smaller, higher voltage battery. Well, it's also physically fairly large. Yeah. So if somebody were to try to convert a radio like that with 1-volt tubes to a radio that can be plugged in the wall, you would create a 1-volt supply. It's actually 1.5 volts, I believe. You'd create a 1.5 volt supply. You might do it with a transformer. You might build a power supply to produce it. Going from feeding the tubes with a DC 1.5 volts to an AC 6 volt is a big difference. It's a big difference. It's too big. It just can't be the case that somebody rebuilt this thing. Oh yeah, the transformers are hanging out here. So I'm relying on this number. When the manufacturer of this radio, the manufacturer may have made some upgraded ones with this set of tubes. No, he couldn't. He couldn't have done that because it's a battery-operated radio. And, well, it could be battery-operated with 6-volt tubes. Could it continue to be a battery-operated radio with 6-volt tubes? You just need a 6-volt battery. I haven't found any information that suggests that's the case, though. All I found is a schematic for what would be the original radio. Would it be then that, having altered the assembly line in the factory, now he's building 6-volt battery-operated radios, continuing with this exact same plate, or wouldn't this become E? Wouldn't this become F? 8B 62E. There's a lot of intelligence in this number, but it's not. It's exactly the same as what appears on the schematic that shows 1-volt tubes. Oh my gosh. The real question for me is, so what do I do next? What do I do next? What do I do next? It's so far-fetched to think somebody did this, redesigned and rebuilt this radio. It's far-fetched. But what else is the explanation? Now, I have looked in my tube substitution guide. This is a pretty good one here. For a couple of the 1-volt tubes to see if you could substitute for 6. And of course, you can't in this book because the heater voltage is wrong. So they don't include any kind of real changes. All the 1-volt tubes, they just suggest other 1-volt tubes. They don't say put in a 6-volt tube and jack up the voltage. That means I have to do a little studying in the in the tube book. And see, I just can't believe this. See what the difference is between the tubes that are in here and the tubes that are on the schematic. I can look them up and compare the goods. I can't believe it. It's just really not believable. I mean, if somebody did all that work, what are all these old wires doing in here? What are all these old wax capacitors doing in here? Nobody would do all that and leave these parts in. I keep looking for a schematic. I think I've come up dry on that. I don't know what to do. So I'm going to go drink some coffee. Okay, I'm trying to think through this as logically as possible. So these transformers were not with this radio when it was first came out of the factory. There's no chance. Without these transformers, there's no 6.3 volts in the radio. No 6.3 volts, there's no way to run these tubes. Unless you had a 6-volt battery, see? unless they upgraded the battery requirement. You see, that doesn't make a lot of sense. I mean, the whole idea of the battery-operated radio is it doesn't draw much current, so your batteries last a long time. So they have low current, low power vacuum tubes in them that just will not drain out the battery. These tubes, these will put a heavy load on a battery. You'd need a pretty substantial battery to power these things. You know, if you're going to. And back in the day, these radios were on probably 5-6 hours a day, every evening, I would think. So it wouldn't be long before you drain a battery with these guys. There's 1, 2, 3, 4, 5, 6 of them. So, you know, each one's 2-3 watts. So you're looking at 6 times 3, 62. You're looking at around 20 watts. So, yeah. Now, somebody's penciled in these numbers, the tube numbers. But, oh, there's so many considerations here. Even the output transformer for the output tube would probably have to be different. Now, this radio's come with this speaker with its output transformer on it. I guess you could just cobble things together and, you know, cross your fingers. Now, when I have had the radio operating, it does have issues. There's a pretty annoying, what sounds to me like intermodulation distortion, and it didn't seem to be something you'd really want to play and listen to, not at this point. Of course, my earlier assumption is, well, a few capacitors and a little bit of adjustment, and, you know, it'll be certainly within the range of being reasonable to listen to. But maybe not. Maybe with all these changes, if this is the case, that somebody's completely redone this is absurd. It's absurd. I can't believe it. I cannot believe it. Could it be there was a kit? Maybe a kit. You get a kit, and in the kit is a box. It's got the tubes in it. It's got some parts in it. It's got instructions in it. No, I can't imagine that. It's too big a job trying to change the tubes completely. It's beyond the pale. I really want to settle this before I continue. Maybe there's some more hints just in the way things are laid out in the back here that if I study it for a while, maybe I can pick up a few more hints about things. I need more than just a few. I need a lot of hints here. Now, what's the big concern? No schematic, no idea what the person did. Can't figure out why he left these old capacitors in there. What's the thinking going on? Lots of old wires, but now that I'm looking at them, you know, they don't seem to be laid out quite the way you would expect in a factory. And that's a bit of a long shot to say that. But and one thing that I did notice is where there's two identical tubes here, 6C5s, in the original schematic, there are two identical tubes here too, 1H5s. Maybe I'm going to start right there and say, could you easily do something and then stick in these 6-volt tubes and do something to the bottom of the radio? You know, there is a fair bit of change going on in there. Resistor here, capacitor there. Let me just try that. How similar is a 6C5 to a 1H5? They both have the number 5. Let me look into this. Okay, this is a little hard to show on the camera here, but it's a 1H4, it's not a 1H5. So there's a 1H4 used as detector or voltage amplifier in battery operated receivers. This type may be supplied with pin 1 omitted, octal socket, filament voltage, actually 2 volts. I was saying 1.5, 2 volts they've written here. Amps 0.06, 60 milliamps, very, very small current. Typical operation. Yeah, okay. Here's the outline. Take a good look at that. It's not complicated. Heater, grid, plate. Now we'll go to the 6C5. Heater, grid, plate. Cathode on 8. Oh, I went and closed the book. Done. 1H4. 1H4, 1C5. Cathode on 8. Tain't no cathode. No cathode here. Of course there'd be no cathode, because these tubes are designed to be as efficient as possible. And placing a cathode around the heater makes the radio just a little less efficient. You've got to heat the heater up higher to heat the cathode up. That takes more power. So one of the ways you get away with the tiny amount of power in the heater is you actually use the heater as the cathode itself. So there's a difference. But otherwise, the pin arrangement is the same. You'd have to move, I guess, the cathode wire off the heaters. And this would be to pin 8 in this case. I mean, there's all kinds of other considerations here. I'm just looking at the layout. I have to chart. Yeah, okay, it's a little hard to compare in this book. The actual, plate current and all that stuff, but it's all going to be totally different. I can't imagine it's in any way the same. There's no chance you pop out 1-volt tubes, pop in 6-volt tubes, shove 6 volts into the radio, and you're glory bound. Is it really like that? Could you do that? Could you just say, well, they used to put 2 volts, I guess, 2 volts DC into here. Well, I'm going to put 6 volts AC into here. It's going to show up in all the same heater pins. So if the tubes I put in are the same in terms of the heater pins, they'll all get their 6 volts of heat. I can't imagine. I can't believe I'm even talking about this. But I guess I have to work through it somehow and get to some kind of conclusion about what has happened to this radio. And interestingly enough, too, these two tubes match the shape of the 2 original tubes. They have. There's a name for it. I don't know what it is, but there's a name for this shape. So that's just a wild coincidence. Is it even worth talking about? I'm just losing my mind here. Is what's happening. I'm down to the shape of the glass now to try to get some. How'd they shape that glass? Oh, that explains everything. Yeah, I don't know. I gotta stop again. Yeah, I still got more coffee to drink. Okay, so I think what's happening here to me is I'm overwhelmed with the situation here. There's too many things to think about all at once. Too many things to try to resolve. Oh my gosh, look at this. What did he just find? Here's a terminal, a tube socket terminal, with no wires attached to it now, but it had wires attached to it. I can see the remains here. They've been cut away. There's nothing attached to it now. There's no pin from the tube above. The actual tube doesn't have a pin that goes into this particular terminal. That happens with some tubes. Well, there's a pretty strong indication right there of a significant variation in the way the radio is wired. Now, it's possible the original tube also had a free terminal here and it was just used as a connection point, and the guy doing this work did the connections differently. But I think this is saying something here. You know, and in changing the tubes out, there are a lot of parts you wouldn't need to change out. Parts like maybe the volume control, this band switch, all this stuff would stay exactly the same. So we expect to find this to have original kind of wiring in it. Whereas the area where stuff has potentially been done, a lot of changes have been made in these tubes. You'd expect to find a lot of changes up here, and it does look that way. It does look like. Oh my God. Seems to me the best way for me to go forward, since this is too much for me to chew on, is to break it down into small pieces and then chew on one piece. And maybe the best way to do that is to either pick the power supply or the first tube. Now, I'm going to pick the first tube. The power supply is pretty much an additional thing. But if the tubes have been changed, then that's all involved in all these parts, and that's what I really want to get a handle on, I think. So we would take a look at the first tube on the radio, which is going to be this tube. And maybe what I could do is I could sketch out as best I can a bit of a circuit diagram for the tube. It's hidden under here. Yes, it's this one right here. This is the one that's got the wire that I noticed the other day was soldered through it. In a way that mimics what happens in a factory, but was not of factory quality. See, none of these wires really fit properly. Like, see this one's got excess wire here. In the factory, they would tighten that up. You don't want to waste wire and put an extra 5 feet, or not 5 feet, maybe an extra foot of wire into each radio. That's a foot of wire per radio. Make 1,000 radios. That's 1,000 feet of wire thrown away. Could have been profit. So all these, even this one over here, this is part of what would not have been changed. It looks a little excessive too. So I don't know. Different factories did things differently. Okay, so this wire ends here, and then there's an extension around to the terminal here. This is not something that would be done in the factory. It looks more and more like that's what really was done. Somebody actually changed out the tubes. You know, this is a nice radio. Like, nice radios are nice radios, but this is not a miracle radio. It doesn't even have a glass dial that's lit up from behind it. It's what I'm suggesting there is, who would want to put all that time and effort into this radio? This would be one of a million. Looks nice now, but back then it was just one of a million. Why? And could you do this work and not have the cost of the work be more than what the radio's worth, or a new radio's worth? Pretty tough to see how that would be the case. You'd end up with a repair bill that would be bigger than buying a new radio with updated technology and a glass dial with a light behind it. So this one had to be done almost by a friend in a way, I would think, or a very serious hobbyist who's doing somebody a favor. My understanding is this radio went to a shop and came back. And nobody knows the details of what happened at the shop. But I could have that story wrong, because people tell me stories all the time and I get them all mixed up. So maybe I got this one mixed up too. But obviously, this had to be done in a fairly serious environment, like a shop. Somebody didn't do this in their garage, that's for sure. Okay, so plan is circuit by circuit, stage by stage, inch by inch. Starting with this tube, it will examine the way the radio is wired up here and compare it to the best schematic I've got so far, and just see how different it really is. So it's going to take me a little while to make that diagram up. My gosh, what am I into here? I mean, ultimately my objective is to make the radio work reasonably well, but I don't think I can do it without understanding the circuitry in the radio, because the radio's not performing well now. Changing a few capacitors in here may improve it a bit, but I have a sneaky feeling the bad hum that's in this radio is persistent. And it's not a power supply hum. The power supply is good. It's getting in through some other way. My guess offhand, it's coming in through the heaters in these tubes. I don't know for sure though. Okay. I know what I'm doing. I think I know what I'm doing. Okay, I've got to show you this. So you can see I'm working away on the diagram here. This is the tube in question, and I'm just tracing every wire carefully away from it to see where it goes. And I got to this wire right here. See this wire? This one here, this red wire going over here. Where's it going? It's going nowhere at all. It's actually cut off and just hanging in here. Oh, wait a minute. No, it's not. What? Oh, no. There's a little piece of wire on it. Whoa. What's going on there? Let me get the other camera going, because that looks like a wire coming back from a coil. Okay, so we're looking at the end of the red wire. You see a bare copper thing? Oh, really? Oh my gosh. Okay, is that the same wire? I don't think so. Oh my gosh, this is really hairy stuff here. Where are we? You can see the wire soldered onto the end of the red wire. And then, well, there's a big coil right here. But look at the size of the wire. Oh, there's some fine wire right here. Bit of solder. The red wire is up here. And what is this? What's this thing? What's this? Shoved into the top. Piece of paper. Well, we can argue oh my gosh, the two wires coming out of this coil. One is connected here, and the other is connected to that red wire. And just left hanging there. Oh my gosh. Well, what does this tell you? This tells you that that red wire used to go to a terminal, and it made it up with the other wire, the light wire there. the uninsulated wire. It's actually insulated with varnish. It made it up with it on a terminal, but he couldn't use the terminal anymore, so he lifted the wire off the terminal but left this connection and left it floating, which is obviously not what goes on in factories. They put all connections onto terminals to make them rugged. I'm like the conclusion. I'm already reaching a conclusion. That's really what's happened to this radio. Somebody's come along and converted the radio to run on 6-volt tubes and dealt with some, if not all, of the consequences of trying to do that. I mean, this is not something you should do in a shop. This is something you do in a laboratory with top engineers figuring this stuff out, with the ability to mock up circuits and try things out and move stuff around. Almost certainly, if you do this in a shop environment like mine, you'd end up with a radio that probably works, but is kind of limping. Probably has hums and buzzes in it, and you can't deal with them because you just, you don't have a laboratory to do it. Oh my gosh. And what's the piece of paper there for? Guarding the wire from something. Well, what are you guarding it from exactly? Holy smokes. Yeah, boy. Oh my gosh. I gotta come up with some new exclamatory phrases. What's this terminal doing with nothing connected to it? And the other one in the back there. You can see the one in the back. Well, this is where the wire once went. Wait a minute. Yeah, this is maybe, well, why wouldn't they continue using it? Why would he, if the coil wire, which is usually the way they make these things, they put the coil wires on. The coil wires end at a terminal. See, there's a terminal down there. And then you hook up the hookup wire in the radio to the terminal. And so you can build these coils in on a bench, and then bring them over to the main assembly line, and you just pick the coil out of the box and stick it in the radio you're working on. I'm afraid to look around more. The wire comes up the middle of the coil form and then reaches this terminal here. So what do? You pull the wires out. Well, what happened? Maybe the coil was bad? So the thin wire suggests the possibility of burning it out. It's not very, it's not a common thing. The heavy wire, that would never. You'd have a smoke-filled house. That wire would still be conducting current. All the soldering here is new. Oh my gosh, I mean, I'm just gonna listen to me whine on this video, and that's about all that's gonna happen. Just whine about this. Well, I should continue with what I was doing. I wanted to just show you this one wire which went nowhere. It turns out it goes somewhere. As I have often said, working on these radios is like doing a puzzle. Only the people don't even tell you what the parts are or what they look like of the puzzle. And you have to find the parts of the puzzle pieces. And then you have to put them together. And what can often happen is you get the first few pieces and you start trying to put them together. This is a human condition problem. We do this with everything. We get enough pieces of the puzzle that when you stick them together, it looks like a tree. It's a tree. But then a few more puzzle pieces show up, and it turns out it's not a tree, it's a car. But then more puzzle pieces show up, it turns out it's not a car, it's an airplane. That kind of thing. Exactly when you stop looking for more puzzle pieces is a big problem for human beings. Or another way of turning this around, this is something I've said a few times. Investigations don't end necessarily with the truth. They end when the investigator is satisfied he has the truth. So think about that for a little bit. It's a human thing. It's just the situation. We face the world We gather information serially. There's no parallel input. I guess there is kind of a parallel input, isn't it? Eyes, ears, all that stuff, but you know what I'm getting at. It takes time to sort these things out. Okay, so I'm going to continue on this diagram because I'm on a diagram of discovery. Painful discovery. Okay, I'm not expecting you to do this comparison because my own note is kind of sloppy to look at, but so the tube in the radio is a 6A8. The tube on the schematic is a 1C7. They are both functionally the same kind of tube, a pentagrid converter tube. As I go around the different tube connections here for the 1C7 versus what's actually in the radio, and they actually match up. So pin 1 is open on the C7. This pin 8, is the cathode on this tube, which has a cathode. But you see the C7, if you look at the diagram, there's no cathode. It's a directly heated cathode, or just no cathode. There's just a heater that's used. And if we go around, the next one is plate. Then we have the two screens. Then we have the grid closest to the heater or cathode, grid 1. Next one over is grid 2. And then we're back to a heater and around to the cathode. And then there is a, I didn't draw it here, there's a grid cap. And here, the grid cap is called grid number 4. Grid number 4, well, it's the fourth grid up. Grid number 4, which is actually the signal grid. And that's going to match on the on this tube. The grid cap is the signal grid. Well, okay. Well, I'm going to stop now. It's a rainy day here. Thank you, rain. Thank you, rain. There hasn't been rain here for like 3 weeks, which is why Canada's on fire. There just hasn't been a lot of rain around. So I don't know about where the fires are. That's a long ways from here. But the air is pretty clear today, luckily, and I think we're into some better air now for a while. But whether the rain fell on the forest fires, I don't know. I guess the whole world is getting interested in the situation here. Could my house burn down? I have not discussed this with my wife. I don't care to. I don't even want to trigger the thought. You know, I live in an urban town. I'm not on the edge of the town. Yes, there's a tree canopy that loosely connects out into forested areas, but fat chance on fire ever spreading into the town I live in. There's 30,000 people here. It's not a small town. So the towns that are in trouble are more remote and surrounded by forest, and usually are much smaller. 5,000 people, a couple thousand people, that kind of thing. Don't know if any major areas are under threat at this point. Don't know. Okay, that's enough of talking about the fire. There we are. I think the conclusion that can be reached at this point is somebody did swap out all the tubes in this radio, found reasonable alternatives for every one of them, put them in, made the alterations that were necessary, which were not 100%. You can see how this tube kind of lined up more or less with this tube. You found ones that you could do this with. Perhaps there was an instruction in a magazine way back when talking about doing this. I don't know. It's an awful lot of work. It's hairy work. And the chance, for me, the way I would assess this, if I were facing this with 1-volt tubes and somebody said, can't you just swap in 6-volt tubes? I'd say, are you kidding me? No. Nobody can do that. That would present so many deep engineering problems in the course of doing it to get a good result. Really tough doing this. Looks like somebody did. It's like a miracle in front of me here. And I thought it was all about this. No, it gets way, way, way further than that. So I think, okay, I can conclude that yes, this is what's happened to this radio. I can conclude I will never find a schematic that's going to be terribly helpful for much of this radio. Wires have been moved around a little bit here and there. The guy who did it appears to have known what he's doing. I mean, I don't think anybody would enter into this without having a pretty good confidence that they can make it all the way through and get a result. So I'm going to leave all those thoughts in my head today, and tomorrow I will start doing actual work on the radio, because I think I know what I got on my bench at this point. You know, if I jumped right in and look at the schematic and start doing stuff, I'm bound to get into trouble. It's a good thing that I discovered all this, as much as it makes the whole job, I don't want to say more difficult, just makes it very, very different from working on a radio that matches its schematic. Okay, challenges ahead. Thanks a lot for watching, and we'll see what happens tomorrow.